Lesson 62 is about classifying triangles. Now let's just remember from Lesson 7 we talked about classifying angles. And triangles are made of three angles, right? We can have an acute angle, we can have an obtuse angle, and we can have a right angle that's always designated by a little box on the vertex. Now, as far as triangles, we can classify triangles according to their angles and also according to the lengths of their sides. Classifying them according to angles, we can have an acute triangle where all of the sides are less than 90 degrees. We can have an obtuse triangle where one side is greater than 90, and we can have a right triangle where one side equals 90 degrees. One side, or I'm sorry, not one side, but one angle is a right angle. Acute triangles, all angles, I kept saying sides, I don't mean to say sides here, I'm talking about angles. Acute triangles, all the angles are less than 90 degrees, or all the angles are acute angles. In an obtuse triangle, just one of the angles is obtuse. And then in a right triangle, just one of the angles is a right angle. So we can classify triangles according to their angles as acute, obtuse, or right triangles. Then we can also classify them according to their sides. If we classify them according to their sides, there's three different ways we classify them: scalene, isosceles, and equilateral. Scalene triangles have no sides that are the same length. Isosceles, iso means same. They have two sides that are the same length, and we can designate those two sides using little tick marks, and that means that those two sides are the same. And then equilateral, equa means equal, lateral means side, equal sides. Equilateral triangles have all three sides the same length. Now, like I'm doing there, I'm drawing tick marks to represent sides that are equal in length. So on a scalene triangle, we could put one tick mark there, two there, three there, to represent that no sides are the same length. Different numbers of tick marks mean different lengths of sides. Now let's talk about angles and how they relate to the different sides. Look at the scalene triangle to start with. Notice the side opposite the angle opposite the side with one tick mark. This angle right here. The smaller the side opposite an angle, the shorter the angle is. So on this isosceles triangle in the middle, the side opposite this angle is the smallest side. That's pretty easy to see there. We can put one tick mark, a green tick mark on it to represent those two things that we're comparing. And actually I'll put two tick marks just so I don't confuse you as far as you may be thinking that all those sides are the same length. The smaller the angle in a triangle, the smaller the side opposite that angle. Now notice that in an isosceles triangle you have two sides that are the same length. And what that means then is that the angles opposite those two sides are equal to each other. These two angles right here are equal to each other. Those blue angles are going to be bigger than that green angle because the lengths of the sides opposite them are longer than the side opposite the green angle. Just think about it. If you had two angles that had vertices starting here and here, and those angles, you were drawing them out to that line that I've drawn there, that line segment. Here's the short one, or smaller angle. This angle smaller than this angle. That bigger angle, see, it covers a greater distance than that smaller angle. The smaller the angle, the smaller the length of the side opposite that angle. the bigger the angle is, or the vertex, if you want to use the appropriate word for a triangle, the bigger the vertex, the bigger the side opposite that vertice. Well, you know that in that isosceles triangle, the angles opposite the equal sides are the same angle measures. They both have the same measure. It should make sense then in an equilateral triangle that all three angles are the same measure because all three sides have the same length. And we already have talked about equilateral triangles before when we talked about the sum of the angles inside a triangle adding up to 180 degrees. In an equilateral triangle, since all the angles are the same length, they all equal 60 degrees in measure. That's what all the angle measures are equal to in an equilateral triangle. Being able to classify triangles according to their sides and according to their angles, that's going to be an important thing to know how to do. You'll use that a lot in geometry. Let's go ahead and do some practice problems here. Classify those three triangles according to their angles. So the first one, that would be an acute triangle, because none of those sides are greater than 90 degrees. If you need to help you understand if they're acute, right, or obtuse triangles, you might get your protractor out and just line it up on the sides to see if any of them are greater than 90 degrees. On B, that would be a right. Right triangles are always the easiest ones to classify because we always know that they are, since they have that right angle box in there. If they don't have a right angle box, then they're not going to be right triangles. And then C, that's pretty easy to tell that this angle here is greater than 90, so that's an obtuse triangle. In D, E, and F, classify those triangles according to their sides. So in D, you see two sides are the same length. That tells you it's an isosceles. Kind of a weird word, so try to spell that right. I-S-O-S-C-E-L-E-S. And then the second one is a scalene, because all the sides are different, right? And then the last one would be equilateral, because all the sides are equal. Equa means equal, lateral means sides, equal sides. Look at problem G. You've been given an isosceles triangle. P, that stands for perimeter. The perimeter is 14 inches. And then the triangle is drawn there. You see the base is 4 inches. I want you to find out what X is. Well, just think about it. If the perimeter is 14, you can subtract 4 from that, and that would give you 10 inches to split between those two sides. Isosceles triangle has two equal sides, so splitting that means that X would be 5 inches. Each side of each of those equal sides are 5 inches long to get a total perimeter of 14 inches. Now look at problem H. I've given you a triangle there. You can tell that's a scalene triangle because all the sides are different lengths. What I want you to do is just rank the angles or the vertices from the smallest angle to the greatest angle. Just put like a number 1 for the smallest one, number 2 for the second one, and number 3 will be the biggest one. So remember what we talked about on these? The smaller the side opposite an angle, the smaller the angle is. And so what we do is we just start with the smallest side. That's the 8 side. Look at the angle opposite it right here. That would be angle number 1. That's your smallest one. Number 2 would be opposite 10. Number 3 would be opposite 11. Your biggest angle is opposite the longest side. Make sure you understand all these different relationships between angles and sides on triangles. Now, unless you go into architecture or something like that, you won't use all these different names for triangles a whole lot in your everyday life, but you will need to know them to study in your study of geometry. Okay, well that's all for lesson 62.